Okay, time to configure area 2. In this area I have two routers, and as you can see there is only one entrance to area 1, and that's going to be this Ethernet one on here. So what this means is we have only one ABR for this area. Now what we are going to see after configuring this is on area 0 we are going to see some LSA type trees, which is going to be the summary LSA. Also the same thing on area 2, but I'm going to check the database. I'm going to see what kind of information we have inside an area which we are missing when we send the information to the other side. So let's go to router 12, and I have Ethernet 1 connected to router 3, and I'm going to configure router 3 as well. So if I just go to here and say interface ETH1, that is the interface connecting to router 12. So that's going to be IP address of 10.10.123, which is 12 and 3, right? Yes, 12 and 3. And let's say that this is 3/24. So this is going to be added to OSPF automatically, but there is something that I need to just check it here. So if I just show the configuration, running configuration of router section router OSPF. So what do we have here? Do we have section? So I have section router, and we don't have section. So let's say that we are going to see all the configuration, whatever it is. So if I just go down, you see that I have just configured all the interfaces with 10 in area 0 or 0000. It doesn't really matter which one you are going to go with. Both of them are going to end up in 0000. So if you have area 1, you go either with area 1 or 0001. Okay, so I'm going to consider this specific interface, and for that I need to be a little more specific about this. So what I need to do is to say do show IP interface brief, and this is why I told you that you need to be a little more specific. Then I'm going to say router OSPF 1. I'm going to say no network 10.10.00/16. What I'm going to say is 10.10. So we have 23 under this, and not this, of course. Let me just go back to here and say no, because I need to be specific about this mask. Okay, so we have 23 and we have 13 under area 0, but I'm going to say network 123 is going to be under area 2. Like I said, you can go with this or you can go with this format. So I'm going to go with this one. I'm going to say commit. So now if I show run and check the running configuration of OSPF, this is what I have right now. Okay, so everything seems to be good. Show IP interface brief after committing. It's going to have this interface IP address here. So let's go to router 12 now. On router 12, I'm going to log in, and using the default username and password in configure terminal. Host name is going to be R12. Interface ETH1 is going to have an IP address of 10.10.123.12/24. Interface loopback is going to have IP address of 12.12.12.12/32 secondary. And then I'm going to have router OSPF1. Router ID is going to be 12.12.12.12. And network, I have all my interfaces in area 2. So I don't really need to be very specific. I can just type 0000/0 like this. under area 2 and then commit the configuration. So this is going to create an adjacency for me. So if I say do show IP OSPF neighbor, it should say that I am now in full adjacency with router 3. And again, I should really configure the interface with point-to-point, which I'm going to do, of course, in a second. I would say interface EAT1. IP OSPF network is going to be point-to-point. And also EAT2, which is connected to R13, is going to be in point-to-point. EAT2, yes, in point-to-point mode. And interface is going to have an IP address of, that's going to be between router 12 and 13. Let's say that I'm just going with 0 or 25, something like this. 10, 10, 25, 12/24. So I'm going to say commit. And on router 3, the only thing that I need to do is to say IP OSPF network type is going to be point-to-point. Point-to-point. And commit it. Okay, let's configure router 13 and go back to database and see what we have here. So I'm going to have en configure terminal, host name is going to be R13, and then I'm going to have interface EAT2, IP address of 10, 10, 25, 13/24, interface loopback, IP address of 13, 13, 13, 13/32 secondary. And then I'm going to have router OSPF1, and again, I can have router ID of this, and network is going to be 0000/0 in area 2. So I can say interface EAT2 is configured with network type of point-to-point. And then I'm going to commit the information. Okay, now that I have done this, if I say do show IP OSPF neighbor, I have no neighbor for now, but now I am in adjacency with router 12. Now let's check the database on this router. Show IP OSPF database says that I have this LSA type 1, which belongs to area 2. As you can see, it says that this belongs to area 2. If I just go down, there are some interesting information here. Summary, which is LSA type 3. And I have received all this information, all of it, from router 3. I have links about routers 1 and 2, 1 and 3, 1, 4, 1, 6, 1, 5, 2, 3, 2, 4, and all these links. And the only router that has given me all this information is router 3. So if I just go back to here and check, this is my router 3, which is my area border router, or ABR. So that is why we are receiving the information from this, because there is only one exit point to area 0. This means that I can change the area type on area 2, because area 2 is a stub area. As a matter of fact, it is not connected to any specific other specific area. So that would be wise if I just configure these routers, every router 3, 12, and 13 as a stub, and then check the database again. I'm going to do this. Before doing this, let's go to router 1, and I'm going to check the database here as well. So if I just log in and then say show IP OSPF database, you see that I have information from router 12 and 13, and this is received from router 3 because router 3 is my ABR. Now I have full information about other parts of the network, and what I'm going to do is to say show IP route. And show IP route tells me that there are routes from inside my network. You can see all the networks are here: 12, 13, 14, 16, 23, 24, 25, 26, and 123 as well. And then I have some intra-area information from the other side. And interestingly, the network 25 is between 12 and 13, which is available for me. And then if I just try to ping them, if I just say ping 10, 10, 25, 13, this ping should go through, and it says the destination is unreachable. So let me see what the problem might be. So if I just say show IP route, and this, it says that it is known via OSPF, distance is 110, and there is a metric here, and it says that the last update was from router 5, and router 5, as a matter of fact, is on here. It is not received from router 3, which is interesting. So let me see what the problem might be. So it says that from router 2 as well, which is down here. So let me see if this Ethernet 4 is configured and working. So if I say show IP interface brief, ETH4 is configured with 10.10.13.1. So if I try to ping 10.10.13.3, so router 3 is available. So if I trace this, trace 10.10.13.3, it should go directly to there. So trace route actually, and it just goes directly to router 3. So why is 10.10.25 not available? And the interesting thing is it says it is intra area, which shouldn't be, as a matter of fact. So if I just go to router 12 and check the interfaces, do show IP OSPF interfaces, and not this, of course, with brief keyword in the end, it says that Ethernet 2 is in area 2, loopback is in area 2, Ethernet 1 is in area 2. So every interface is configured in area 2. And of course, I have a neighbor adjacency on this. And if I say do show IP interface brief, it says that Ethernet 2 is configured with this IP address, which is connected to router 13. So if I just try to ping 10.10.25.13, and of course with the do in front, because we are in config mode, this is available. And also if I try to ping 10.10.123.3, this is available as well, because 123 is configured on Ethernet 1, and I should close this one. Ethernet 1, which is reachable to router 3. Now the thing is, now that I have configured this, do show IP route says that I have accessibility to all the routes, and let's say that I'm going to ping 10.10.13.1, and it goes through as well. So if I try to say I'm going to source this from Ethernet 2, source interface actually, or let's say the source is going to be 10.10.25.12. So 10.10.25.12 is not accessible for some reason to router 1, and that is why this ping does not go through. So there should be a problem, because on router 1 what I am seeing is 25 is a local interface, and now I know why, because 25 is configured between router 2 and 5, and I have used the same prefix between router 12 and 13. So I'm going to make a change on here. On router 12, I'm going to say interface ETH2. I'm going to change the IP address from 10.10.25 to, let's say, something like 125. That would be better. 12/24 commit and do WR, of course, and on R13 interface EAT2 IP address is going to be 10.10.125.13/24. That would be better, and I'm going to save every configuration here that I have. Going going back to router 1. Now if I just check to see the IP route, 10.10.125.13, it says that it is available via Ethernet 4, which is this one, goes to router 3, and seems completely legit. So if I try to ping it, 125.13, the ping goes through without any problem. Okay, now we have full information about this, and the only verification command that I want to have right now is this one. I'm going to say show IPOSPF database, and this is for summary, of course, and the network is going to be this one, of course, 0. And here we have some interesting information about this specific prefix. So for me, it says that the summary link is in area 0. That's quite tangible because we have received it from another area. And which router was the actual advertiser? It is the ABR, which is 3333. And then we have this path available through 3333. Okay, and this type is summary LSA, of course. Okay, now that I have done this, I'm going to change the network type in the next video. What I'm going to do is to say, because this network is a stop network, as a matter of fact, it is not used as a transit network. Basically, this stop means this. And what I really want to do is to say, okay, I have only one exit point, so why should I have so much information in area 2? So if I just go to router 13 here and check the database, you can see that the database is pretty much packed with all the prefixes here, which I do not really understand why I should have them, why I should use my memory on them, why I should calculate all of them, while all of them are reachable via router 3. So instead of having all of them, why should I not go with a default route, and why should I not use that? So this means that I can just change the network types to different available types of networks in next video, and I'm going to examine the database to see what we have in terms of LSAs.